Hi everyone, in this video we will find the nth order derivative of a given function. It means you have to find the general rule for any order of the derivative. So in these questions you have to find f prime, you have to find f double prime, f triple prime, the fourth order derivative of the function. After that you have to see what is the relationship between the order of the derivative and the derivative itself. To understand well, we have to start with part A, and the question is find the nth order derivative of the function of x equals 1 over x plus 1. Before we start the derivative, you have to simplify the function, and all the students knows you can write it as x plus 1 to the negative 1. This is the first step. Secondly, you have to find the first derivative, but before we start to find the first derivative, we have to revise the power rule and the chain rule. So if you want to find the derivative or the first derivative of a function to the nth power, you have to put the power down, then you have to multiply by the same parentheses you have, the same function, to the power n minus 1, so you have to subtract 1 from the exponent. Then you have to multiply it by the derivative of the inside function. So this is the power rule and the chain rule. So in this function, f prime of x equals, you have to put negative 1 down, so you'll get negative 1 multiplied by the function itself to the power negative 1 minus 1, which is negative 2. So this is the first derivative. Now you have to find the second derivative. So the second derivative will be f double prime of x. It is a derivative of the first derivative, so you have to put negative 2 down, and you'll get negative 1 multiplied by negative 2 multiplied by the function x plus 1 raised to the power negative 2 minus 1, which is negative 3, multiplied by the derivative of the inside function. But the inside function is x plus 1, so the derivative is 1, so no need to multiply it by 1. Now the third derivative of this function, f triple prime of x, is negative 1 multiplied by negative 2 multiplied by negative 3 multiplied by x plus 1 to the power negative 3 minus 1, which is negative 4, multiplied by the derivative of the inside function. But the inside function is x plus 1 again, and the derivative of it is 1, so no need to multiply it by 1. Now last, you have to find the fourth derivative. Then you have to see what is the relationship between the order of the derivative and the derivative itself. So the fourth derivative of x is negative 1 multiplied by negative 2 multiplied by negative 3, put down negative 4 multiplied by the function itself, then subtract 1 from the exponent, and you will get negative 5. Then you have to multiply by the derivative of the inside function, which is 1. No need to write multiplied by 1. So we found the first, second, third, and fourth derivative for the function. Now you have to see the pattern. For the first derivative, we can write it as negative 1 factorial multiplied by x plus 1 raised to the power minus 1 minus 1. So this is the first derivative. Now what we can write the second derivative. The second derivative is negative 1 multiplied by negative 2, which is 2 factorial. It will be positive, multiplied by x plus 1 raised to the power negative 2 minus 1, because we can rewrite negative 3 as negative 2 minus 1. the third derivative is equals to negative times negative times negative, so the answer will be negative. Now 1 times 2 times 3, it's 3 factorial multiplied by x plus 1. Now we can write negative 4 as negative 3 minus 1. So this is the third derivative. And the fourth derivative, we can write it as, we have 4 negative numbers multiplied with each other, so the answer will be positive. And 1 times 2 times 3 times 4 is equals to 4 factorial multiplied by x plus 1, and write negative 5 as negative 4 minus 1. Now we want to see what is the pattern, how to find the nth derivative of this function. So if you compare the order of the derivative, here the first derivative, you see that have 1 here and you have minus 1 here. Okay, here we have the second derivative 2, so here we have 2 factorial, and here we have minus 2 minus 1. So minus 1 is fixed for all the derivatives. Now the third derivative, again, here we have 3 factorial, and here we have negative 3 minus 1. So there is a pattern in the derivatives. Now what about the fourth derivative? And the fourth derivative, here we have 4 factorial, and here we have negative 4 minus 1. So if we want to find the nth derivative of the function, the nth derivative or the nth order derivative of the function of x, this is equals n factorial multiplied by x plus 1 to the negative n minus 1. But pay attention here, the first derivative is negative, the second derivative is positive, and the third derivative is negative, and the fourth derivative is positive. So it's alternating, which means you have to put something multiplied by the formula of the nth derivative, and this one will be negative 1 to the nth power, because negative 1 to the nth power, it will be negative 1 when n is even, when n is odd, and it will be 1 when n is even. So here when the derivative is even, the answer will be positive, and when the derivative is odd, the nth derivative will be, or the derivative itself will be negative. So you have to multiply by negative 1 to the nth power. I will put it as a note here. So negative 1 to the nth power in general equals to negative 1 when n is odd, and 1 when n is even. So if you have alternating and you want to find a closed formula for something, you have to put negative 1 power something, okay, which is negative 1 power n, our equation. Now you have to simplify the nth derivative of the function. So the nth derivative of x equals to negative 1 to the nth power multiplied by n factorial divided by x plus 1 to the power n plus 1. Why that? Because here we can write x plus 1 to the negative n minus 1 as x plus 1 to the nth power plus 1, and you have to take negative 1 as greatest common factor, and this we can write it as 1 over x plus 1 to the n plus 1. and that's it. So this is the nth derivative of the given function. Now in part B, find the nth order derivative of the function of x equals 1 over x minus 1. You will have the same procedure, and first you have to rewrite it as f of x equals x minus 1 to the negative 1. Then you have to use the power rule for differentiation, which is from the chain rule, and it's easy to find that the first derivative of this function will be minus 1 factorial multiplied by x minus 1 to the negative 1 minus 1. Okay, you can check and find it. And f double prime of x equals 2 factorial multiplied by x minus 1 to the negative 2 minus 1, and f triple prime of x equals negative 3 factorial multiplied by x minus 1 to the negative 3 minus 1. It's exactly as the same in A. You have to use the same technique to find the nth derivative of this function, because in the first one we have 1 over x plus 1, and the second one we have 1 over x minus 1. So what's the nth derivative, or the nth order derivative? So the nth order derivative will be negative 1 to the nth power multiplied by n factorial multiplied by 1 over x minus 1 to the n plus 1. So divide by x minus 1 to the n plus 1. Now in part C, find the nth order derivative for the function of x equals to x over x squared minus 1. There is a hint to solve this question. This is the hint. 2x divided by x squared minus 1 equals 1 over x plus 1 plus 1 over x minus 1. And as you know, if we have addition between two functions and you have to find the derivative of the sum of two functions, the derivative distributes in addition and subtraction. So the nth derivative of this function equals the nth derivative of 1 over x plus 1 plus the nth derivative of the function 1 over x minus 1. So the nth derivative of the function 1 over x1 is part A, and the nth derivative of 1 over x minus 1 is part B. So the nth derivative of this function equals the nth derivative for the first one, which is negative 1 to the nth power multiplied by n factorial divided by x plus 1 to the n plus 1, plus the nth derivative for the function 1 over x minus 1, and the nth derivative for this function is in part B, and this is equals to negative 1 to the nth power multiplied by n factorial divided by x minus 1 to the n plus 1. Now you can simplify this formula, and we can take the common between the two terms, and the common is negative 1 to the nth power multiplied by n factorial. So these are the common between the two terms, multiplied by 1 over x plus 1 to the n plus 1 plus 1 over x minus 1 to the n plus 1. Now you have to multiply the first one by x minus 1 to the n plus 1, and down you have to multiply again by x minus 1 to the n plus 1. Also here you have to multiply by x plus 1 to the n plus 1 to rationalize the denominator to get like denominators. So this is equals negative 1 to the nth power multiplied by n factorial multiplied by the expression x minus 1 to the n plus 1 multiplied by x plus 1 to the n plus 1, and up we have x minus 1 to the n plus 1 plus x plus 1 to the power n plus 1. Now we know that a square minus b square equals a minus b multiplied by a plus b. So if we have x minus 1 multiplied by x plus 1, this will give us x squared minus 1 squared, which is x squared minus 1. So down here we have x minus 1 multiplied by x plus 1, and the two expressions have the same power or the same exponent. So you have to combine them, multiply them, and raise them to the power n plus 1. So here we have negative 1 to the nth power multiplied by n factorial multiplied by the expression x squared minus 1 to the n plus 1, and up we have x minus 1 to the n plus 1 plus x plus 1 to the n plus 1. And this is the end of part C. Okay, and this is the nth derivative of the function we have, and that's it. Thank you.